Hello everyone, welcome to my YouTube channel Chem Corona. Myself Mayuresh Raut, Assistant Professor, Department of Pharmaceutical Chemistry, Sinhagad Institute of Pharmaceutical Sciences, Lonavala. Today we are going to discuss Dakin oxidation. By the end of this topic, the learner should be able to understand what is Dakin oxidation, the mechanism involved in Dakin oxidation, and the various applications of Dakin oxidation. So let us understand what is Dakin oxidation. Conversion of ortho and para-hydroxybenzaldehyde or phenyl ketones into ortho and para-dihydroxybenzene by action of hydrogen peroxide is known as Dakin oxidation. Dakin oxidation is useful in the preparation of polyhydric phenols from naturally occurring hydroxyaldehydes. The general reaction for synthesis of Dakin oxidation is shown below. We start with a para-hydroxybenzaldehyde and the end product is para-dihydroxybenzene, which is obtained in presence of H2O2, that is nothing but hydrogen peroxide. Let us discuss the stepwise mechanism. Step 1 is decomposition of hydrogen peroxide to H plus and OOH minus ions. So this hydrogen peroxide will dissociate to form H plus ions and OOH minus ions. In step 2, there is nucleophilic attack by OOH minus ions to the carbonyl carbon of the aldehyde. So these OOH minus ions which are produced in step 1, they are going to attack on the carbonyl carbon and we will get this intermediate. So this is attacking on the carbonyl carbon. So this double bond will break and it will lead to formation of this intermediate. Step 3, there is migration of 1,7 sigma bond to the electron deficient oxygen. So we can see here, this is 1, 2, 3, 4, 5, 6 and this carbon gets number 7. So there is migration of this 1,7 sigma bond to the electron deficient oxygen atom. We can see here directly this oxygen is getting attached to the benzene ring. So that's why it is called as 1,7 sigma bond migration. Step 4 is nucleophilic attack by alkaline NaOH at the carbonyl carbon of the CHO group to yield intermediate 1. So this OH minus is going to attack on this carbonyl carbon and this double bond will break, leading to formation of intermediate 1. Step 5, there is loss of formic acid from intermediate 1 upon heating. So from intermediate 1, there is loss of HCOOH and we will get our required sodium phenoxide ion. And the last step is acidification of the sodium salt using H plus and H2O2. So this phenoxide ion will get acidified with H plus ion and we will get a dihydroxy compound. Applications of Dakin oxidation include first application, that is synthesis of hydroquinone from para-hydroxyacetophenone. So if we start with para-hydroxyacetophenone, we are going to get hydroquinone as this will be converted to OH. Second application is preparation of pyrogalol from 2-hydroxy-3-methoxy benzaldehyde. So if we start with 2-hydroxy-3-methoxy benzaldehyde and if we treat it with H2O2, that is hydrogen peroxide, we are going to get pyrogalol as the end product. That is, this aldehydic group will be converted to OH, that is 2,3-dihydroxyanisole, which is also called as pyrogalol. So that's all about Dakin oxidation. Please like, share and subscribe my channel Chem Corona. Thank you for patient listening and happy learning.